Hi, my name is Shari Liu. I am a postdoctoral researcher at MIT, and today I'm here to tell you about a specific aspect of common sense reasoning in human babies, specifically understanding the minds and actions of other people. So look at this picture and ask yourself what's here. Well, we can easily identify the people and the things in the scene, but we understand a lot more. So we see this baby who has a particular goal in mind, for example, that toy in the foreground, but their little body is too short, and they're trying really hard to overcome the physical constraint of that table to reach their goal. And the point of this example is to say that we observe scenes like this, but we make sense of them using underlying causes. We appreciate the mental world of this person, their desires and their percepts and their beliefs, and we see them as a solid body acting in a physical world, who exerts forces and pursues goals with respect to their own physical limitations and those imposed by the environment. So as a cognitive scientist who studies babies, I want to ask babies what they think about scenes like this. And of course, they can't say anything back yet. Some of them can't even perform simple actions like reaching or crawling, but we can still learn something from them by measuring their visual attention, seeing what they expect and prefer. So decades of research in developmental psych has suggested that babies are sensitive to many aspects of people's actions. So first, like adults, they respond to whole bodies, hands, even simple geometric shapes and treat them as agents. That is, they expect these entities to have solid physical form, to pursue goals, so to have perceptual states, to pursue the path of least resistance towards their goals. And babies appreciate that agents, in some sense, intervene on the world, for example, by causing things to happen through their actions. But a key question is what form this knowledge takes. Are these separate, disparate abilities, and is learning just an accumulation of these individual insights? Or do these findings attest to another form of knowledge, knowledge that captures how the world works in abstract terms, that allows us not only to recognize what's there, but to explain why and to imagine what could be different? So these proposals are at the heart of developmental psychology, but we're in a unique position to get evidence bearing on this because we have cognitive science and computational cognitive science to thank for this. So these fields have provided formal proposals for how these conceptual systems could work that include uh, scientific theories, folk scientific theories of psychology, including variables like cost and reward, variables that abstract away from individual things that we've seen and done, and that trade off in precise quantitative ways. And they include causal relations that allow us not only to see what's there, but to work backwards from these observations to infer causes of action that are unobservable, like preference or confidence or belief, and to make flexible predictions about what's going to happen in new situations. And the argument in this talk is that babies have something like this abstract, coherent knowledge about actions and minds. So, the main claim here is that infants, like adults and like older kids, have some sense, an early intuitive theory or a precursor for intuitive theory um, about people and how they act in the world. And I'll show you three key pieces of evidence for this claim. So first, I'll give you evidence that babies have graded quantitative representations of variables, in particular of action cost. Then I'll show you that their knowledge is coherent and integrated into a utility function. That is, they're using information about relative cost to learn about reward. And lastly, we're going to look at the role of experience by studying infants who are too young to even reach for objects. And I'll show you that infants actually don't need a lot of first-person experience with specific actions to get some form of this knowledge off the ground. Instead, I'll argue that this knowledge is actually rooted in abstract concepts like causal powers and goals and costs. But first, do infants have quantitative variables pertaining to action? So here I'm going to focus on cost because many experiments have suggested that babies are sensitive to cost in some form. And I'm going to focus on 6-month-olds because they're at the edge of starting to move themselves through the world. So some of them are crawling, but they're certainly not leaping or reaching over, or even reaching over barriers yet. So the specific question is whether babies at this age expect other agents to minimize cost, to do what's easy, all else being equal. So what we do is that babies come into the lab, and there's 2 phases of the experiment. During habituation, kids see this agent leap over this barrier towards a goal, and then that happens over and over again until they get bored. And then at test, we put in a new low barrier. And the question is whether what the babies expect about the action of this agent with respect to this new barrier. So if babies expect agents to minimize the height of the jump given the height of the barrier, then they should look longer when the agent performs the very same high jump that it did before. So now I'll show you the events. Here's part 1 of the study, where infants are habituated to an agent leaping over a barrier towards a goal. So that goes on for a couple minutes. And here's a few minutes later. So this is the first time that the baby is going to see the new little barrier. And for this baby, they're going to see the efficient action first. So there, the baby looked away for a pre-specified amount of time. So that means that that trial's over. And this is the very next trial where the agent performs the same height jump that it did before, but a jump that is newly inefficient. So I'll just save time and say that this baby looked, for as long as we let him at this event, the full 60 seconds of the trial, and then those two events just repeated 2 more times, which generates an average looking time to the efficient and the inefficient action. So the design of the experiment's on the left. So now I'm going to show you the results. So on the y-axis is looking time in seconds. I'm going to show you 2 box plots. So each line across these boxes is data from a single participant. The boxes indicate the middle 2 quartiles of data. The median is the thick black line in the middle. The mean and the within subjects 95% confidence intervals are in red. And I'm also showing you the effect size, this beta coefficient that's in standard deviation units. So in experiment 1, we found that babies noticed when this agent failed to conform the height of its jump to the height of the new barrier, and they looked longer at that thing. So in 2 other experiments, we showed that this effect is not explained by babies merely preferring to look at higher jumps. So if you do an experiment where you move the barrier out of the way, but otherwise keep everything the same, the effect also goes away. And this finding is also not explained by learning that the agent jumps just high enough to clear the barrier. Because if you run this 3rd experiment, pairing the habituation events from experiment 2, there's nothing in the agent's way. And then at test, the new little barrier gets introduced for the first time. So that the first time that the kids see the barrier actually block the agent's path, babies still look longer at the inefficient high jump. So just to sum up, these experiments build on prior evidence that babies are sensitive to action cost and provide evidence that infants actually have graded representations of this variable and that they expect other people to minimize the cost of their actions. And next, I'll tell you that, show you evidence that just a few months later at 10 months, infants have coherent action plans in mind when watching other people act. That is, they not only represent the graded cost of people's actions, but they use information about cost to infer other hidden causes like people's preferences. So here, we're testing what babies can infer from seeing agents do costly things. So here's part 1 of the study. You're going to see this red guy act towards 2 goals, and you're going to see that this red guy is willing to do higher cost actions for one of these goals than the other.
Hmm. 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 Hmm.
So this repeated many times, but in these 4 events, what we see is that this red guy is willing to jump a higher barrier for the blue guy than the yellow guy. So the question is, which of these goals does the agent prefer? So to test this, we showed babies the agent choosing each of these goals in turn. So on the left is the lower value choice, where the agent chooses the yellow guy, the guy it took lower cost actions for. On the right is the higher value choice, where it chose the blue guy, the guy it took higher cost actions for. And the key prediction,
Hmm.
yes, this is what the events look like. Great. And the key prediction is that the baby should look longer at one of these outcomes. And the argument here is that they should only be able to succeed at this task if they can appreciate that effort is in some sense informative about value. And that's how we're testing for coherence here, specifically the integration between cost and reward. So here we tested 10-month-old infants because of the higher task demands relative to part 1. So on the left is a schematic of the study design. And just to be clear, we designed these events to control for many things, but not everything. This design controls for how often the kids see this red guy vocalize positively or negatively towards the 2 goals, the frequency of the relative frequency with which the agent actually jumps versus refuses to jump. Also, all the actions are equal in duration. Here are the findings from the test events. So what we find is that infants look longer at the lower value action when the agent chose the goal for which it worked less hard, suggesting that they expected the alternative. And after this, we ran 2 further experiments manipulating costs in other ways. So for experiment 1, right, the agent's leaping higher barriers for one goal than another. In experiment 2, we manipulated cost just by manipulating the angle of that inclined plane that the agent climbs or declines to climb. In experiment 3, we manipulate the width of a gap that the agent jumps or declines to jump. And across these experiments, we're controlling for vertical motion, horizontal motion, speed, time, path length, such that none of these features uniquely predicts the cost of actions across experiments. We found in every case that infants are looking longer when someone does high cost actions for a goal and then decides against choosing that goal later. So I think this suggests that for a baby, the effort might be grounded not in terms of variables that happen to correlate with cost, like time and distance, but maybe something more abstract, like the physical work that's needed to carry out that action. So Tomer Ullman, a key collaborator on this project, built a set of probabilistic generative models and shows that indeed we need integrated representations of cost and reward and rich notions of cost and reward to explain these results. And I'll look forward to hearing everyone's thoughts about what other classes of models could account for them. So just to sum up, I think this is strong evidence for the proposal that infants have what constitutes an early intuitive theory of other people's actions. That is, they represent quantitative variables and trade-offs amongst them. This allows infants to infer why things happen the way they did, and babies can use these hidden causes to make predictions about what's going to happen next. And I want to highlight that their reasoning is not restricted to people and actions that they see every day. And our choice of using these stimuli is intentional. We're basically testing whether babies, in fact, are able to go beyond the particulars of their experiences. And I'll show you one more piece of evidence that they can. So in the previous 2 sets of studies, babies seem to reason about characters that look nothing like real people, doing actions that they themselves cannot do. And the last thing I'll tell you about is another case of using real people as stimuli this time. And we're going to test for actually babies who cannot reach for or grasp objects. We're going to ask what those babies know about that action, reaching and grasping. So remember that even though reaching and grasping for objects is a really trivial action for human adults, even though it's a really, really common action in infants' perceptual experience, it's really complicated. There are lots of ways that hands can interact with objects, and successful grasping and lifting depends on things that are often opaque to vision, like pressure and mass and texture. So no wonder it takes infants 4 to 5 months to figure out how to successfully reach for and grasp and lift objects, and more months to manipulate them in fine-grained ways. So the question here is, what happens if you take 3-month-old babies who cannot reach for objects and you show them people reaching for objects. So here, consider these two kinds of actions. One is grasping and lifting an object like this. The other is touching the object and causing it to light up. Now, ask yourself, which do you think a 3-month-old would be better at reasoning about? Well, one thing you might be thinking about is their perceptual experience. So reaching and grasping are really common. They see people do this all the time. Even if they themselves can't do it yet, 3-month-olds are probably working on trying to. So maybe that's easier. But actually, the empirical finding is that they're really bad at understanding this action. So if they see a person reach over a barrier to lift an object up, they don't look longer when a person does that efficiently versus efficiently when that barrier gets removed. That is the fail aversion of the first set of studies that I showed you. Maybe that's not surprising, right? 3-month-olds are not good at a lot of things. But what is surprising, and what we showed in this paper, is that babies succeed when you show them this much rarer action. And we argue that they succeed in the case on the right because this action conveys a much more abstract feature of action. That is, it conveys a clear cause and effect. So if babies see someone reach out, touch the object, and make that object change state, now they do what the older infants do. That is, they're looking longer at the inefficient version of that action. So for babies who've never successfully reached before, seeing that a reaching action causes a state change like that helps them interpret this action as physically constrained. So if you take the barrier away, they look longer at the inefficient version of the action over the efficient one. And in fact, this actually only works if the person contacts the object and causes it to light up. So if you take away the impression that the person causes this outcome like this, using this very subtle manipulation, that very subtle manipulation actually takes away their expectations about efficiency. So we found this in one experiment and then replicated it in a second one, and we fully replicate these results. So what does this mean? Well, in the absence of experience reaching for objects, babies are tuned into abstract features of action. They go beyond reasoning about what they've seen others do even. And I think this mirrors the other findings that I've been telling you about. So instead of thinking about the state of early social intelligence as just an accumulation of experience and with it new knowledge, I think about early social intelligence as instead supported by early emerging concepts like cause and cost and goal, and how these concepts work together to generate people's actions. So I think it's really interesting that babies focus on very general properties of agents and actions that allows them to reason about actions they've never experienced, agents that they're not familiar with, and in fact, this could actually guide their own exploration through their own actions. So in sum, I presented work showing that in the first year of life, infants appear to hold systematic knowledge of other people's actions. That is, they interpret other people's actions in terms of continuous abstract variables like cost and reward, and coherent plans over those variables. And their understanding goes beyond the infant's own specific experience. I'll end by saying that this is one view of many, using one method of many in order to collect evidence for or against this view. And I'll say that this is just the beginning. So I'm really excited by workshops like this because they really bring together people who I think are going to push developmental science forward. So if we want a full understanding about the origins of common sense in babies, we'll want more than what I just presented. We'll want large-scale quantitative studies of infants' behavior that generate quantitative data for quantitative model fits. We'll also want to develop measures other than looking time that are more information dense, that speak to the underlying mental processes that guide longer looking, right? And ones that are temporally precise, that allow us to study prediction and learning as events are unfolding. And finally, I think the whole point of collecting these data is to test and develop formal models of the infant mind, the kind of model that can go from movies to expectations about people, places, and things. So I'm really excited by this future of scalable ways of integrating models, theories, and empirical research on the origins of common sense. So thank you all for your attention. I'll thank my collaborators, my funders, the organizers of this workshop, and I'd be happy to answer a couple of questions. Thanks so much.